Welcome to today's episode on C programming in C++. Today we learn about pointers, arrays, and structure. So without wasting my time, we get down to the business. What is a pointer? A pointer can be said to be a variable that stores the address of another variable. Stores the address of another variable. Pointers can be used with any data type. Creating a pointer. A pointer can be declared in the same way as other variables, but with an asterisk symbol, which is this. So this is the basic structure of a pointer, and this is an example of a pointer int ptr. So assigning addresses to pointers. In the assignment of addresses to pointers, an initial a pointer, the address of symbol, which is the ampersand, determines the address of any variable in C++. So let's say we have a variable of value to be an integer variable and it's equal to 22, and want to assign the value in the val address to the pointer. We have to use the address of operator, then the name of the address, the name of the variable. We input that one there, it automatically assign it to the assigning address to pointers. As I said already, the value in the val variable was assigned to the pointer pr to ptr. So why do I always make that mistake? Let's continue. Difference in a pointer. The process of accessing the value present at the memory address pointed by the pointer. That's what is referred to as difference in a pointer. Okay, so an example here is int asterisk the ptr, the pointer name, is equal to the variable address, the address of the value they want to access. The address of the value they want to access in their variable, the address location. So ampersand val, then you see out, you print out the value which was assigned to the pointer. The value the pointer is pointing to. The value the pointer is directing you to. That is what was printed out. So if you come here modifying a pointer, this is the basic structure of a pointer. And a pointer can be modified by just using this method, this by using the name of the pointer variable, that's the ptr, initializing it and equating it, initializing it and directing it to another address which is of the same data type. If it's not of the same data type, it wouldn't work, it would give you an error. Modifying a pointer address, just like I said, this is the basic structure and how a pointer is modified. This is it. So to get the size of a pointer, you use the size of keyword, just like we did in our previous video. The size of keyword, then the variable name. The variable name is inputted into the brace and it's printed out for you. Special types of pointers. We have the wild pointers. Contains random memory address that may or may not be valid. That's int ptr. Null pointers. Points to non-valid memory location, but null. Points to no valid memory location, but null. Initializes a pointer that does not need a memory address pointed to it. That's int, that's a pointer, then the null memory address does not need a memory address. We have the void pointers, point to value with no particular type. Dangling pointers point to earlier valid addresses even though referenced memory address is erased. How then is a reference? A reference works as an alias for an existing variable. Sorry. Providing an alternative name for it and allowing you to work with the original data directly. Referencing versus pointer. A pointer allows you to pass potential large amount of data around at low cost. Instead of copying the data very simply, instead of copying the data, we simply pass its address to a pointer value. Creating reference. Ampersand is used to create a reference. So with an example, we have t ampersand ref is equal to value. So if you have int with a variable, an integer data type with a variable name of x is equal to is initialized with a value of 10, the reference is going to be int, that's the data type, with the reference symbol, that's the ampersand, just like we said, the address of the reference symbol. So since you are referencing, you are making the system get to know a specific address, a certain portion you want to talk about. So then you use the address of symbol, which is the ampersand. Then the name of the variable, that's the reference you want to use. The int ref is equal to then the variable name x. Application of references. Passing arguments by referencing. We can pass arguments by reference. Example int main, then integer data type with variable name x is initialized with a value of 10. Modify value x. Find modification value int x modifies the original value variable x is equal to 20. Can referencing from functions. Properties of referencing. You access a reference with exactly the same syntax as the name of the object. A reference allows refer to the object to which it was initialized. There is no null reference. Arrays. An array contains multiple objects of identical type stored sequentially in many. Individual objects in an array are called array elements. Array elements can be addressed using index or subscript. This is the basic syntax for an array. The type of array, the data type of array you want to define, the name of the array, and the size. This is an example of a float array. The float data type is name ARR with the size of 10. The size of 10. Index of array. Index specifies the position of an array that starts from 0. The subscript. The subscript operators. The square brace is used to access individual array elements. Element in an array, the array name, and the square brace with the variable with the index specified to the element. Initializing an array. Initialization of arrays refers to defining the element it contains. A list containing the values of the individual array is used to initialize the array. Example is this int the variable name, then the size of the array, then the values you want to assign to each location in the array. Accessing array element. Accessing array elements refers to viewing individual array items. Just like I said in the previous, the array name, then the index specified to the element in the array. Multi-dimensional arrays. Arrays with columns and rows. Two-dimensional arrays are data type array and size of the first column and size of the second column. Declaring 2D array. 2D arrays have two rows and two columns. Can be visualized as a table or matrix. Integer data type of an array variable has four rows and four columns. This can be simulated with an Excel file. Clearing 3D array, just like the 2D, you add an additional column to it. It has four rows and four columns, and it's deep by 3. Four rows, four columns, and it's deep by 3. Structure. The struct function. So a struct is a sequence of elements or arbitrary types. A struct is a sequence of elements or arbitrary types. It's used to create user-defined data types. You can have the struct name, the type that's the data type, the name, the variable name. This can be said to be a valid example of the use of the struct. This is a well-defined user data type. Here we have it again. Creating a struct variable. After creating a struct variable must be created. After creating a struct variable must be created. So the struct name and the variable name. Struct name and variable name. Creating a struct variable. If the struct name is summer and the variable name is if the struct name is address, the variable name is summer. This means this is the structure and this is the struct name. Just like gravity, structure and variable name, struct name and variable name. So this here is the structure name and the variable name. A struct variable can be declared with its definition: a struct name, data type, variable name. Creating a struct variable with definition. So we have it, and the definition for the struct is Julia. Assessment struct. A struct member can be accessed using the dot operator. This is the basic structure to access a struct member. And we can access Julia's age from here, since this can be said to be the definition. So this was used to define what element of Julia's struct are we accessing. We are accessing the age element of Julia's struct. A struct member can be assigned using the assignment operator. We have the value, the variable name. That's the struct name. Variable name, the member name, and equal to the new value. Here you have it. The definition, that's the variable name, the element initialization operator, the new value. A union is a struct that holds the value of just one of its elements any at any one time. So a union, just like other user-defined data type, have a define has to be defined before we can use it. We have union name, the data type, the variable name, and this is a basic example of it. We have union, then the age, that's the type, the type, variable name. Creating a union variable. After creating a union variable was created. So to create a union variable, we are supposed to have the union name and variable name. So there we have it. We have the union name, student, the variable name, Juliana. A union can be declared with its definition. If you have the definition of a union to be Juliana, that's after the curly brace, the curly brace. After the curly brace, that's where the definition is placed. So with that, you can access any element of the unit by using its definition. A unit number can access the dot of the structure. So if you have this union member, then if you have this union member, then the union variable name. So the union variable is Juliana. Sorry, Julia. Then there's the member. You use the dot operator to access the member age. Use the dot operator to access the member age from the union. A union member can be assigned using the assignment operator. All members share the same memory. Only one element can store a valid value. Accessing value through other variable may lead to undefined behaviors. That means only one element can store a valid value in the union. That's when it's age. If we assign the value to age, that means no other variable in the union can hold a value. Structure versus union. Union allocates Structure allocates memory for each member variable sequential. The size of a structure is the sum of the size of its members, including padding for alignment. Members can be accessed independently at any time, used to group related data of different types. Union. A union allocates memory only for the largest member value. Only members can share the same All members share the same memory location. The size of a union is the size of its largest member. Only one member can be active, used to save memory when only one of several members is needed at a time. Enumeration. An enum is a type with a set of named constants called enumerators. It holds a set of integer values specified by the user. The possible values are named and called enumerators. There are two types of enumerators: this is the enum classes and the plain enums. Enum class use enum classes for defining enumeration. Enum class color red, green, or blue defines an enumeration called color. Enumerators are red, green, and blue. So this is an enum class, and the enum class defines the enumeration called color, and these are the enumerators: the red, green, and blue. Plain enumerators. Plain enumerators can be unnamed. Unnamed plain enumerators are used when a set of inter, integer constants are needed rather than a type of a type to use for variables. Unnamed plain enums. So this is the enum type, then wait. Thank you for this.